We'll start with the two span problem. You can see AB span is 40 Newton and UDL, and BC span is 20 Newton. FEM, finding out the FEMs first. Finding out FEM first, you should draw two separate beams. This is one beam, that is AB. So here the moment developed will fixed end moments. Fixed end moments, I told you what is fixed end moments. This is BA. At every end there will be fixed end moment. This is denoted as MFAB and this as MFBA. So MFAB, when it is a point load, I told you the formula is minus WL by 8. Minus W. What is W? W is 40. What is length? Length is 4 divided by 8 meters. So MFAB will be 160 divided by 8. That is 160 divided by 8. That will be minus 20 kilonewton meter. So moment is meter. Next, MFBA. What is MFBA? MFBA is plus WL by 8. Plus W is 40 into 4 divided by 8. That is plus 20 kilonewton meter. Okay, now going for the BC span. This is joint B and this is C. So first step is finding out the FEM and considering the ends as fixed. Ends as fixed BC. So MFBC. MFBC, this is UDL acting. MFBC, that is minus WL square by 12. This is the formula for UDL. Minus W is 20 into L square is 6 divided by 12. So this will be minus 60 after you calculate. 6 ones are 6, 6 twos are 2 will cancel, 2 10 into 60. So MFCB is equal to plus WL square by 12. Plus WL square by 12. So for this plus W is how much? W is 20 into L square. L square is how much? L square is 6 meters divided by 12. That is plus 60 kilonewton meter. This is kilonewton meter. So this is the step 1. Step 1 is finding out the FEM. This is step 1. That is FEM. So how far you find out FEM? It is here. So considering the span AB and span BC separately and considering the ends as fixed. So for point load you have one formula, and that is minus WL by 8 plus WL by 8 right hand side. And for UDL you have one formula, that is WL square by 12 minus plus WL square by 12. Right hand side is positive, left hand side support is negative. Okay, after this step 2 is the condition of the beam. What is the condition of the beam? Seeing the beam, what are the conditions? So here you can see the A and C are fixed. So when a beam is fixed, so if you see a deflected shape of the beam with this joint, when the beam is fixed, it has this kind of deflection. Okay, deflection is this kind, where at the fixed there is no development of slope. Slope is what? Slope, this is the slope. Okay, there is no development of slope. This is theta, this is slope. So at the fixed end there is no development of slope. So theta at C is equal to 0 and theta A is equal to 0. So development of slope at the fixed end, it is 0. So condition theta A is equal to 0 and theta C is equal to 0. Theta B means theta B, and here there will be some theta B. We don't know what it is, but there is theta B also exist. There is some development of slope at joint B. So development of slope is there at joint B. So this is the condition, and delta is the delta. You can either show like this or either you can show like this. Delta is 0. Delta is 0. Why delta is 0? Because there is no sinking given in the problem. So he has given a two-span problem to analyze SFD and BMD. Okay, theta is 0. So next step 3 is slope deflection equations. So in the last class I told you slope deflection equation MAB for AB member. For AB member, this is the AB member. When you want to have the moment, what is MAB and MBA? Okay, you need to fill the formula is MBA is equal to MFAB. This is the slope deflection equation derived, plus 2EI by length is 2 theta A plus theta B minus 3 delta by L. This is the formula. So for MBA it is MFAB plus 2EI MFBA 2EI divided by length 2 theta A plus 2 will come to B, 2 theta B minus 3 delta by length. Okay, so this is the formula to find out the moments, slope deflection equations. Okay, so what we have, EI is constant, given here will be EI constant. Okay, M for member AB, MFAB, we have this. So we'll write down how many slope deflection. There are two spans are there, so we'll have 4 equations. Okay, for AB member, MAB is equal to MFAB plus 2EI by length 2 theta A plus 2 theta B minus 3 delta by L. So what is MFAB? MFAB, here you can see MFAB is minus 20 plus 2EI. EI is constant, write down as what is length of member AB? Length of member AB is 4 meters. Theta A is 0 plus, it is not 2 theta, it is only theta B. Theta B, this is also 0. So the equation will be minus 20 plus 2 ones are 2 twos are. So 1 divided by 2 is 0.5 EI theta B. This is equation 1. Okay, now what is MB? This is equation 1. Minus 20 plus half means 2 ones are 2 to the 0.5 EI theta B. So what is MBA? MBA is MFBA plus 2 EI by length theta A, 2 will go that side, 2 theta B minus 3 delta by length. So what is MFBA? MFBA, you can see it is plus 20. So plus 20, 2 EI by length is again 4 meters, same member. Theta A is 0 plus 2 theta B minus 0. So what will be this equation? 20 plus 2 ones are 2 twos are 1, 2 twos are 4, 4 divided by 4, that is 1, that is EI theta B is equal to, this is your equation 2. Okay, this is what? Slope deflection equations. Slope deflection equations. Okay, for AB member you have 2 equations. Similarly for BC member you should find out another 2 equations. So we'll do that here. Okay, for BC member, so for BC member, MBC is equal to MFBC plus 2 EI by length 2 theta B plus theta C minus 3 delta by L. Okay, so what is MFBC? MFBC is minus 66. FEM, this is FEM. F means FEM plus 2 EI. What is the length of the span? Length of the span is 6 meters. Length of the span is 2 meters. So I here given as EI is not constant, EI has some value. EI for this, it is 2i, and here it is I. Okay, so substituting in place of I, it is 2i, theta b, 2 theta b as it is, plus theta c is 0 minus this 0. So what will be the equation? Minus 60 plus 2 2s are 4. This is 2i. If it is not clear, just see it is 2i. 2 2s are 4, 4 divided by 6, 4, 2 2s are 4, 4 2s are 8, 8 divided by 6, 8 by 6 ei theta b. So simplify this equation, minus 60 plus 4 by 3, it will be 4 by 3 minus 1.33 ei theta b. This is equation 3. Similarly for MCB, MFCB plus 2 ei by length theta b plus 2 theta c minus 3 delta by. So what this will be, MCB is plus 60 plus 2 ei by 2i, length is 6 meters, theta b plus 0 minus 0. 60 plus 4, 4 is 4 by 4 ei theta b by 6. So 4 by 6, so that is 2 by 3. So it will be 60 plus 0.66 ei theta b. This is equation 4. So you found 4 equations. 4 equations. So that 4 equations are there. And so next, considering equilibrium condition. Equilibrium conditions. So what are the equilibrium conditions? So at any joint, summation of moments, and a rigid joint is there, summation of moments is equal to 0. That is summation of moment at joint. Which is rigid joint is B. Summation of moment is equal to 0. So at joint B, you can see the member is like this. This is joint B. At joint B, there will be 2 moments, MBA plus MBC. Okay, so therefore MBA plus MBC is equal to 0. So this is the one equilibrium condition where you should use. Okay, so how many unknowns are there? There is one unknown. One unknown is there, and you have one equation. One unknown, one equation. So you will get one unknown and one equation. You will get one unknown, that is theta b. Theta b is one unknown. So you will have one equation, and with that one equation you will get the theta b value. So MBA. So what is MBA plus MBC is equal to 0. MBA you will get in equation 2, and MBC you will get in equation 3 from slope deflection equations. This will name it as equation A. Okay, what is second equation? Second equation is 20 plus ei theta b plus, this is equation 3, 1.33 ei theta b. So what will be the equation here? Ei theta b, that is plus 20 minus 60. So 20 plus ei theta b minus 60 plus 0.33 ei theta is equal to 0. So minus 40, 1 and 1.3, that will be 2.33 ei theta b is equal to 0. 2.33 ei theta b is equal to 0. 0. 40 will come that side, there will be plus 40. Plus 40. Therefore ei theta b will be 40 divided by 2.33. When you divide 40 by 2.33, it will be sir. Try. Okay, so EI theta B value is 17.143. So substituting this value, in equation 1 to 4, substituting these values in equation 1 to 4. So when you substitute, what is equation MAB is, what was equation MAB? 0.5 EI theta B minus 20. This was the equation. So EI theta B value, when you substitute 17.4 there, you will have 0.5 into 17.143 minus 20. So here this value will be 11.42, and multiplying you will get 11.42. Similarly, MBA, what was the MBA equation? It was plus 20 plus EI theta B, 0.5 EI theta B. So 20 into 0.5, 20 plus 0.5 into 17.14, that will be equal to 37.14. Similarly, MBC, what was MBC equation? 60 plus 1.33 EI theta B. Substituting the EI theta B value, 60 plus 1.33 into 17.14, you will have minus 37.14. MCB minus 60, MCB, this is minus 60, so it's minus 37. This is plus 60 plus 0.66 EI theta B. So 60 plus 0.66 EI theta B. In place of EI theta B, substitute what? 60 plus 0.66 into 17.14. You will have 71.42. 37. These are the moments. 70. So these are the moments what you are getting. So similarly, when you find out the moments, these are the moments. MAB is equal to minus 11.42. MBA 37.14. MBC is minus 37.14. MCB, it is 71.42. So these are the final moments. Now you need to draw BMD for this. You need to draw BMD. For what is the BMD for this? When you're drawing BMD, you need to take consider free BMD. What is a free BMD first? What is a free BMD for AB member and for BC member? Free BMD for AB and BC member. So what is free BMD for AB and BC member? Free BMD. So this is the, where is the question? Where question is like this. So here is the question. So free BMD for AB member. So it is point load. You can see it is a point load. So WL by 4. This is free BMD formula, maximum bending moment. 40 into length is 4 meters divided by 4. So free BMD is 40 kilonewton meter. For BC member, it is UDL. So WL square by 8. W is 20 into 6 divided by 20 into 6 square divided by 8. So you will have 26. So you will get free BMD as, when you draw the free BMD, you will get, simplify, 90 kilonewton meter. Use calci, you will get this value 90. So now free BMD, this is your free BMD. Now we will draw the BMD diagram. So draw the baseline BMD. Draw the baseline. Okay, this is point A, this is point B, and this is point C. This is 4 meters, this is 6 meters. So for point load, maximum bending moment is 40 at the center. So this is 40. For UDL it is 90. So maximum is 90. So this is 90 kilonewton meter. This is 40 kilonewton meter. Okay, now at the ends, what is MAB? MAB is how much? This is joint A, this is joint B, this is joint C. MAB, you have MAB value. MAB is 11 point. MAB is 11.42. So 11 point, this is 40, so 11 will be somewhere here. 11.42. MBA is how much? 37.41. 37.41 is somewhere here, little below 37.14. Okay, MBC is also minus 37.14. It will be here. What is MCB? MCB will be 71.42. This is 37.14. This is 11.42. Join this. So this these final moments are negative, and this free BMD is taken as positive. Free BMD, whatever it is, taken as positive, and this all is a negative bending moment. Develops hogging, and this positive develops sagging. So this is the fine BMD diagram.